For our next example, we're going to take a look at the scope of variables and methods in a C# class. And as part of this, we'll talk about various other scope rules as well. Now, within a given class, any fields of the class, those are the static and non-static variables declared outside the class's methods and properties. Any methods of the class, any properties of the class, those all have what we would call class scope. In the class's scope, the static methods and properties can see all of the other static members of the class, and the non-static methods and properties can see everything in the class. So again, let me just reiterate that. If it's a static method or property, it can see within the class all of the other static methods and properties and fields as well, such as the static variable at line 8. If it's a non-static method, it can see everything inside the class. So a non-static method not only can access the instance variables and other non-static properties and methods, it can also access all of the class's static methods. So in this class's scope, we have several things at class scope. We have the field called x, which is an integer that's declared to be a static member of the class. Now, we declared it static because all of our methods in this class are static, and we want them to be able to use x if we need to. So within the class's scope, main can see x, and the other methods can also see x in this example. So we have the field x, we have the main method at class scope. We also have these other two methods, use local variable and use static variable, that are also at class scope. And because every single one of them is static, technically all three of these methods can see the static integer variable x with the value 1. However, when you declare a local variable that has the same name as a field of the class, the field is going to be hidden inside the local scope. So for example, as we enter main here, the first thing we do is create a local variable x and initialize it to 5. Now within main scope, from line 14 to the ending curly brace of main here at line 31, the only x that main now knows about is x at local scope, the one with the value 5, and we're then going to display that value to prove it to you. So if I stop here for a moment and run the program, you can see that the first thing we display is that x's value in method main is 5. That is clearly the local variable x, not the field x with the value 1. After we display that value, we then call our method useLocalVariable, which is defined right below main here. And you can see that useLocalVariable also defines its own local x variable, this time initialized to 25. And to prove to you that it's separate x from the one in main and from the field x with the value 1, we go ahead and display that value, then add 1 to it and display the value again. So if I stop there for a moment and come back and look at the next two lines of output, the x on entering useLocalVariable was initialized to 25, and as we left, its value having been incremented was now 26. Now the next thing we do after that call to useLocalVariable is we invoke useStaticVariable. Now if you look at useStaticVariable, you'll notice within the body of this method we do not define a variable x inside of these curly braces or in the parameter list of the method. So when we refer to x in this context, the compiler first looks for a declaration inside the curly braces and doesn't find one. Then it looks for a declaration at class scope. And we have the field called x, the static integer called x, which was initialized to 1. So lines 48 and 49 display x's value as we enter this method. So if we stop there, we can see that the static variable x on entering was 1. Then we multiplied x by 10 and stored the result in the field x, the static variable x, and we displayed x's value again as we left the method. And that produced the second line of output here, showing that the static variable x has the value 10. Now the next thing we did is go back to main. We just finished this call to useStaticVariable, and now we're calling useLocalVariable again. Local variables are created as they're encountered and destroyed as the block in which they're defined terminates. So as we call use local variable again, we get a new version of the integer x with the value 25. We display its value again, increment it, and display its value as we leave. So once again, we can see that x upon entering was 25 and upon leaving was 26, just as it was before, because every time we call the method, this variable gets created again. And then we once again call use static variable. Now, because use static variable is using the field x, and we modified x to be 10 last time through, when we call use static variable again and enter this method, the value of x is going to be 10 initially, then we'll multiply it by 10 and display 100 before we leave the method. So you can see here in the last call to the use static variable method that x was 10 as we entered and 100 as we left. And this emphasizes the fact that if you have a field of the class, it's maintaining state for you between calls to the class's methods. If you have static state, it's there for the purpose typically of maintaining state for the static methods of the class. If you have instance variables, those are typically maintaining state for a particular object of the class. So static variables are for the class itself. Instance variables are for individual objects of the class, and we'll be talking about that in a lot more detail as we get back into some of the object-oriented programming concepts in later lessons. Now, the very last thing we did in main is to display once again the value of x in main, and again this is still the x that was created at the beginning of main, so it's still in scope, and therefore we expect to see the value 5 once again, and you can see in the last line of the output that indeed x was 5. So we talked in this example about local variables, and then at class scope we talked about a static variable and static methods of the class. Now, just a couple of other things that you should know about scope in general. Number one up here, the scope of a parameter is just the body of the method in which that parameter's declaration appears. We already showed you what happens with a local variable. The scope of the local variable is from the point of declaration until the end of the block containing that declaration. We just demonstrated that both in main and in the use local variable function. And that applies whether the method that you're using the variable in is a static method or a non-static method. It's still local to the method. With a for loop, if you declare the counter variable in the for statement's header, the scope of the variable is the for statement itself. And we already mentioned the fact that properties, methods, and fields of a class are all class scope. Now, there is one thing that's special in C# about local variables in particular. So if I go back over to the source code here, let's say, for example, that the use local variable function were to have a nested if statement inside of it. So let me just go ahead and type if, and we'll just double tab to use a code snippet to fill that in. So if I were to try to declare another variable x here, this is actually not allowed in C#. So you notice I'm getting a red squiggly here, which if I hover over it, it says that this local variable named x cannot be declared in this scope because it would give a different meaning to x, which is already used in a parent or current scope to denote something else. And what it's referring to is the x that was declared in the outer scope back at line 36. So in some programming languages, the x here at line 46 would simply hide the x at line 36 for the duration of the nested scope. That is not allowed in C#. So that's a big difference between C# and some other programming languages. And actually, in my opinion, it helps clarify your code and keep it simpler because you won't accidentally use the same variable name within multiple scopes of the same method definition.